Good morning, friends. Today problem is largest divisible subset 368 is a daily Leetcode challenge. I hope you are like it our daily YouTube videos, updates and explanations. Okay, so statement of the problem is given a set of the distinct positive integers nums, return the largest subset answer such that every pair nums of answer of I answer of J of elements in this subset satisfy. This is the both conditions should be true there. If there are multiple solutions written any of them. Example 1 nums 1 2 3. So might be you are thinking that why we are not tagging 1 2 3 because of 1 and 2 can be possible, 1 and 3 is possible, 1 2 3 is not possible because 1 and 2 possible, 1 and 3 possible, but 2 and 3 is not possible there. That's why we are not taking here 1 2 3. Now example 2 is nums is equals to the 1 2 3 4. Here we are taking all the elements in our answer. Why? Because 1 is divisible by 2, 2 is divisible by 4 and 8, and 4 is divisible by 8 and 4 also, and 1 is also. That's why we are taking all the elements of our question into the answer. What is our constant? Constant is nums dot length. So 1 less than equals to the nums dot length less than equals to 1000. What does it mean? It is mean that our range of the nums dot length will be 1 to 1000, not 1 up to the 1000, and our nums of I 2 into 10 raised to 9 and 1. If they are not given like this, so we have many lead coders what they do, they create the suppose here they told us 100, so what they do, we find anyway find a 1 to 100 table, then they do easily this problem. But for making the more difficulty in this problem, they uh, they just put here range so higher. That's why the problem becomes very hard to think. So all the integers is nums are unique, so you don't need to worry about if what if the elements are duplicates. Suppose 1 2 2 8, this is the not will happen in this question, right? So due to the high number is here, and it exceeds the integer limit, maybe int max is also 2 raised 10 raised to 9, maybe it's a possible there, but 2 into 10 raised to 9 is very large, it is very large integer very number, so it is not possible in normal integer. So we have to adopt a good approach which is dynamic programming. So you can search here what is dynamic programming. So this problem is solved by dynamic programming, also max and little bit concept of array and sorting. Whenever you see the sorting in the topics, you should think that we need to sort, and then after you can think that what if we are sorting, then what is possibility can be possible, right? Okay, so today's solution is not mine, I taken help from discussion section. So let's see the solution. I try to explain you. So for explain you, I just write some steps. Solution is given by mark as Philip 31. So what is our step in the solution? First sort the numbers as you already told you. So if you are seeing topic sorting, so you first try to sort the whatever question is given. After sorting, you have to find the pattern and approach to how to deal with the problem, right? So first of all you should sort the numbers, then dynamic programming approach, then finding divisible subset and track maximum length and backtracking to generate subset. So our overall problem is that, and time complexity is already mentioned here. Time complexity is order of n square and space complexity is order of n. So let's see what the solution is. Okay, so I give me a second, right? Okay, maybe you can see here. Okay, fine. So first of all we take int n is equals to the nums dot length, and max is equals to the 1 and num is equals to the minus 1. Maxi is the maxi is used here to find the uh, subset, right? And num is also be same way we are using here. We are taking vector v, then we are sorting the our nums, as I already told you that why I are sorting, because in topics is more mentioned that in this question sorting is the way we can use here. So you should try to first sort the array and then find out what should the answer go, right? So dp is our dp size will be n is equals to the nums dot size. Then our here dp is approach is begun. There is two for loop where first loop is I is equals to the 1, I is less than n, and j equals to the 0, j is less than I, not j is less than n. You have to uh, observe this, right? Fine. So I do some comments for your understanding purpose. Okay, so what is the first of all you can, here it is for understanding purpose, this is for understanding purpose, and this is for understanding purpose. And in for loop there is a if condition. If nums of I modulo nums of j is equals to the 0 and dp of I is less than dp of the j plus 1, then you have to go inside and update the dp of the I. And if the maxi is less than dp of the I, so you should update the maxi. And after all, I also show you here that what is dp will be. Okay, so in last what we are doing here, we are doing if uh, we doing here condition that the max is equals to the d of I and nums of I. Num of I, what we have, what why are we putting here num is equals to the -1, because in our first condition maybe it is not satisfy, that's why we are doing here. Okay, so maxi if d of I, and what we are doing, we dot push back nums of I, not tp of the I. You should observe this. Then num modulo nums of, for better understanding what you can do here, you just need to here just do this and do this is equal to the 0. Fine. Now for then we are I am showing here your vector that how it looks like, right? And maxi will be decrementing and num will be changing it. It only here used to uh, contiguous subset, finding the subset of the uh, modulo and which satisfy the condition. So here is our comment, all the stuff, right? So num 1 2 3, so for I equals to the 1, j equals to the 0, right? I already told you I will become to the 1 to n and j will move to 0 to I, not equals to the I first of all. So before we initialize our dp is equals to the 1 and the size of the dp is equals to the n, which n is equals to the nums dot size. So 1 2 3, 1 2 3, the size of the one nums of I is 3, so that's why we are putting here the 3 times 1. Now max is equals to the one we already initialized. Now we are in our second for loop here. So what second loop indicates that our condition is what? Nums of I. So I is what? 1. 1 is there, and what is j? J is 0. So dp of the I is equals to the 1 and dp of the j is equals to the 1, but dp of the j plus 1 2, so 1 is less than 2. Yes, then why our, then after we are going in our condition, you can here also see, right? Where it here, here it is, sorry. Yes, first of all, they say here nums of I is modulo nums of j is equals to the 0. If yes, that's fine. If dp of the I is less than dp of the j plus 1, and if both condition is true, then after you can go here inside the for loop, second for loop, right? So dp of the I is updated and max is also updated because max is 1 and now max is becomes 2 because 1 is less than 2. That's fine. So afterward, first dp looks like 1 1 1, and then after passing the first for loop of I equals to the 1 1 2 1. Now here I equals to the 2, and j, what j will be 0 to 1, not equals to the 2. So 1 to 1, it is our last dp. Then maxi is 2, maxi is 2. Now for 3 modulo 1, right, 3 modulo 1, of course there is equals to the 0, that's why. So our dp is updated, and after 1 2 2. But you can observe that our maxi is not updated here. Maxi is updated, but here maxi is not updated, but dp is our updated. So what dp looks like 1 2 2. Now after j equals to 1, I told you 0 1 may be possible, but j will not go to 2. 0 and 1 it will go. So 1, now 1. So but 1 before is 1 to 2, maxi is 2, and 1 to 2. So you can now dp is updated, now max is updated, because of there is no possibilities to do, because you see 3 modulo 2, we have to think that 3 modulo 2 is not equals to the 0. That's why we are not going inside the if condition. So here we end the our two for loops. Now it comes to this last for loop here. So our why here two ticks, because I think so maxi and dp of the I, right? So what is our maxi? In our last what we are saying, maxi is equals to 2, so maxi is 2. What is dp of the I? We are begin our dp of the I in the reverse pass. What you can see, int I n minus 1. So we are reversing, traversing in reversing order, right? So 2 and 2 is equals, that's why in our answer 3 will be included. Then after we decrement the maxi, and our num is also be changed. So num will be, here you can say num, num becomes nums of I. Nums of I is what? 3. The num is 3. Now what will happen? Max is decrement, so max is equals to the dp of the I. So our, you can say that maxi, what is maxi here? So maxi is our 1, right? So maxi is 1, so 1 is 2, right? So 2 and dp of the I, both are same. Yes, so 2 2 is same. And in end condition is num. Num is what? 3. And nums of I is what? Maybe it's a 2. So but you can see here where we are, where we are. It's okay. So 3 modulo 2, sorry, num is 3 modulo 2 is equals to the 0. No, so that's why it will not go inside the condition. Now our maxi is not updated, maxi will be 2, and the I will be updated. So I go to the 0. So what will happen here? So our maxi will decrement. Okay, then. Okay, fine. So our maxi is 1 and 1. Our maxi is 1. So 1 is 1, and then you can our index is 0. So what is our index to 0 value is 1. So num is 3. 3 modulo 1 0. So that's why we are going inside, and we are also including 1 and decrement the maxi, and after all maxi is equals to the 0, and we getting our answer inside the vector of the v. Maybe v, okay, yes, maybe v, not the maybe v, it's the v. Okay, so it is our temporary solution for your understanding purpose. I hope you understand. If you don't understand, so you can see here, and you can put the um, same answer in your Leetcode console, and you can do observation that what is flow of the code, right? And this is our main code. I The code is for only understanding purpose. Here is main code. So let's see the submit. Fine, it works. Okay, I hope you understand. Thank you so much.